Testing, testing. It's always the same thing. I think I think it's always that my OBS, because it doesn't turn on its startup. It never gets first dibs on the microphone, I think. And so it always needs to explicitly get the microphone. Also, testing, testing. The microphone was very, very quiet in my settings. So hopefully this fixes it and we're good now. Hey, Halogen, how's it going? I did say hi before, but not to you. I said hi to my microphone that I had not pressed the button to connect to my streaming. So, Dong's first, Halogen second. Although I think this is what I was saying before, that I think Dong just waits for me to put up a schedule for a stream and puts first on it and then just Batman's away. So who knows? Could be, might not be. Um, so Halogen, I think you missed last week. But we didn't do anything, so it's okay. It was actually really funny. Was starting to look at Godot and someone, oh well, because we had a visitor starting to get busy. Ooh, HobbyCon. Wait, is HobbyCon the one with heaps of collecting things like what's it called, like trading cards and stuff like that? Oh, UNSW runs it. Ah, that would have been really cool. I should have come along to that. That would have been fun. Hang on, hang on. Ooh, we are on the wrong monitor. You get to see the back end. This is what goes up on the second monitor. Um, let me. I think this is all because I've changed some hardware. Okay, so I just recently got a new monitor. Actually, no, recently it came in today. It's one of the hardest things to do working from home when a new monitor turns up. So I've got a new 4K OLED monitor, so it is very, very shiny and it looks really good. The only downside is I can't show you. I can't do anything about it for you because all you get to see is the signal from the monitor, not the monitor itself. And also looking at it, that signal is um a bit grayed out there, and I think that's the kind of thing that happens when you send an HDR signal to a non-HDR output, because that's all gray. Is that looking gray to you? Because I think it is to me. Let me go into settings and turn HDR off, because I think that's probably what the issue is there. All right, yes, that's much better on OBS. So prepared, so prepared. I obviously knew exactly what I was doing before I started the stream. And because it's a new monitor, I'm like adjusting where my webcam is on it. Yeah, so that actually looks like the right colors now. Whoa, this is so bright. So without HDR, it's super, super bright. So let me just save my own face. Wait. That's very strange. I don't have control over brightness and contrast on the hardware on the monitor. All right, we'll just let that go. I'll just be super bright for the evening. Zero, how's it going? How you doing? Okay. Took me a while, but I've got all my hardware set up. So small changes have happened today. I just got a new monitor. It's a what was it? 2725. Yeah, it's definitely this one because I was looking up random stuff about it. It's busy, is it, Zara? Is term about to start again? Is that why it's busy? Because I know that you were all on break for a little bit there, or has it just started already? Anyway, this is the monitor that just came in today. It's hard to describe a monitor when you're kind of just talking about it and everyone's obviously watching on your own monitors. Oh, it's week 4. Look, I should probably be happy that I'm so far out of UNSW's timeline that I can just be like, oh, I have no idea what time is in term. I know what the time is in the things that I'm doing, which means I'm kind of in my own world now. Um, I really actually do want to turn down the brightness. I mean, can you see it? You can see it on my face right now how bright this monitor goes at the moment. Um, Aljan has an assignment due tomorrow night. But for the moment, the brightness and contrast in hardware here is grayed out. And I don't know why that is the case, but I think that on stream right now is probably not when I should be troubleshooting my monitor. So I'm just going to leave it and let it be excessively bright. I'm just going to go to a different screen. There you go. Ring light at home lighting. Yeah, yeah. So what I've done is I've just taken away the white background, and so I've got my desktop here instead. Oh, you just got a BenQ 272Q. You know, I think that I'm not 100% certain, but you probably have exactly the same OLED panel that I have, because it's always funny when you look at it and you go, everyone's got the same thing with the 240 hertz 27 inch, I think it's 26.5 inch OLED panel. And then when you look up information about it, it's like just Samsung makes this panel and it's the same one that everyone's got. The only difference you're going to get is just how different companies have tuned it before they ship it to you. And the hilarity is that the price difference on them is massive. So I could have spent twice as much as this on an Asus or something like that, and hardware-wise, it actually would have just been the same thing. Who knows though if like the firmware and stuff would have been different. Maybe I would have been able to change the brightness and contrast on the panel. I'm still not sure why that's not doing that, but you know. Zero saying the only difference is the BenQ monitor has fancy color data thing. Ah. Oh yeah, apparently the Alienware one that so I went for budget. I went for the cheapest one that I could get, but it's still really good. And what people say is it's not calibrated amazingly out of the factory, but like it's not too bad. Like I can probably get like what other people have said about how to calibrate it and just use that, and it'll probably be fine. Yeah, but so far it's been quite exciting. I snuck in some Cyberpunk on my lunch break and then afterwards today, and it looked really, really good. Like the colors and the sheer contrast. It's really funny having my two monitors, because my old monitor is the one that chat and OBS and stuff is on, so that I can use my main monitor to do other things, but it looks gray in comparison now to the other one. And so now I'm just kind of recalibrating my eyes to believe that OLED is the only way everything should look. So I've just made everything more expensive, basically. Because my normal monitor, which up until yesterday I was quite happy with using, now looks like it's all grayed and washed out and must be horrible. And I think that's how they get you with like new tech, right? If they can get it to look better, enough better that you really, really notice the difference, and you're like, yeah, this is why I'm doing it, right? So it's a lot of fun. The only downside is I went up to 4K, so I've got to readjust all my graphics settings on my games, because I don't think I can run them all on the same the same quality settings, because I think it's literally double the number of pixels when you multiply it out between 1440p and 4K. So I need to kind of figure that out. Actually, just before dinner tonight, I was playing Cyberpunk and I was getting all this massive stuttering. But I think that's a config issue. So I've done something weird with the config of my graphics card, I think, which I need to fix later. I was saying even the Windows default backgrounds look so good next to your laptop. That's pretty cool. I'm lucky though. My laptop is a MacBook Pro, so it does have a very, very nice screen. I actually don't know exactly what the screen is. on the MacBook Pro, but I think it's not an OLED, but I think it's at least a mini LED, like multiple dimming zones, but not like dimming per pixel. Let me check. Oh, okay, where's dark mode? Wait, Chrome doesn't have, Chrome has a dark mode, right? I'm just not finding it. DIY Perks has some interesting. Wait, is DIY Perks that guy that builds stuff? What am I trying to do? Oh, I have to get an extension. All right, you know what? We are not going full screen white. I'm just gonna use a small window now for it. I thought Chrome would have a dark mode. Maybe Windows has a dark mode. I actually don't need that because this is already dark. But DIY Perks, I think, is someone like rebuilds things and does these strange builds and stuff. Oh, I can change it on the new tab screen. Where do you reckon it is? Customize this page? There we go. Yes. Do I need to... No, I don't need the theme. Dark. Did that do anything? It's weird because it didn't change this. Oh, I've looked this up before. Oh yeah, okay, it's gone dark mode. No, it's not monitor. So, is the MacBook Pro OLED or LCD? Upcoming MacBook Pro will utilize hybrid OLED. So I don't have an upcoming, mine's like 2 years old. I think mine's an M2. LED backlit with IPS. Okay, so it's old school, but I think it's at least LED backlit. That's the one that I've got. It's still very nice. So I think like my laptop is still always feels good, you know. He glued together 2 LCD panels to get more accuracy colors. Wait, like on top of each other? Use projectors on the back of the panel to get more accurate local dimming. Oh, that's really awesome. So the light shining through the back of the LCD panel was a projection of the image, so it was exactly the right brightness for the pixel that it was shining on. That's a hilarious idea and also very, very interesting. Okay, I think I can go full screen now without blinding myself. Oh no. No, Google Docs. Google Docs doesn't. Okay, would it be in view? Mode? No. Settings, page setup. Oh, you know what? This is going to be easier to be like. Just Google it. That's a Chrome extension. No, this looks like someone's like wait. Dark theme. Settings theme. Okay. Wait, where was settings? I thought it was in here. Nope, that's Gemini. Tools? Preferences, maybe? This looks like editor preferences. I don't know. I'm just going to shrink it down again so it doesn't blast me too much. Okay. What was I talking about? I was looking at my MacBook, which does have a very good monitor, because like Apples always have really good screens. But now I have an OLED monitor, which is very, very shiny and very nice. If only I could dim it a little to not blind myself. First world problems. I got a very fancy, expensive monitor, and now I'm complaining about it. Okay, let's do some Godot stuff because I don't think Zero and Halogen, I don't think either of you last week where a friend of mine who I haven't seen in ages, who is someone I know through miniature painting, turned up on the stream, and we were just chatting. We ended up just going through like this whole history of stuff I'd painted and things like that, which was kind of fun. But it was very, very much side quest. And so no Godot or coding was done at all. We did have a quick look at the oh right, Halogen saying Google Docs dark mode is only for the apps and not the site. I mean, also it's a bit strange to do a dark mode in a document editor when you think about it, because a document editor has a connotation that what it looks like is what it's going to print like. So if you've got that situation, then if you make it a dark mode, how do you expect it to print? Is it just going to like use up all your black ink doing the whole background of a page? Or is it going to print inverted? And then if it's inverted, exactly what way is it inverting it? So I can see why you wouldn't have it in like a page view kind of thing. Okay. Back with Godot. Wait. Where was I doing stuff with Godot? It wasn't linked from this page, was it? Godot tutorials? Godot documentation? Probably here. Yeah, that's where I've been before. Oh well, at least the Godot website's in dark mode, so I won't be blinding myself that much today. Okay. I was in the getting started bit. And I did player input. Did I do signals? I don't think I did. Yeah, it doesn't look super familiar. Okay, let me show you where I was up to though. So 16th? 16th is the most recent. Oh, it opened on my other monitor. I'm just gonna move it over. Why aren't you? There we go. Alright, let's try not to put it behind my face. Okay, so we were doing input scripting and stuff, so if I just run this... Was it arrow keys? It's arrow keys. I was using WASD, but I hadn't set it up that way. So this is me steering this little object around and being able to drive it and things. So we have, if I press up, it moves in whatever direction is up for it. And if I'm holding down left or right, it's doing an angular rotation based on its rotation speed and the direction. So you can actually see the very, very simple script here. Do I need to zoom in? I probably do, right? Yeah. So the direction is no turning, or turning to the left is negative, turning to the right is positive, and it's just here's learning how to do if a particular action is pressed. And it's nice because it's got these sort of, I don't know, they'd be macros for, or just constants for left and right. So that way you can then bind other things to that. So this also worked with this. So I'm on a controller now, and I'm using the left thumbstick. So you can see as I turn the thumbstick, it is now controlling this. So that's the nice thing about having an engine where the idea of me just picking up a controller while this thing is running and giving it input is actually making it work. And I go back to keyboard now and it still works. So I think that's nice because like the amount of coding I'd have to do to get that stuff going is probably excessive and unnecessary. And I'd have to learn how to work with like controller drivers maybe and stuff like that. So it's nice to have a framework that can kind of just do that for you. So here we have a basic, really simple, if it was going to be a top-down 2D character controller, this would be a starting point for it. Which I found hilarious and ironic because in the game, we're trying to teach people how to code, so we won't actually have a controller. We will have a set of instructions that it will follow instead. But still, learning about how the scripting works and stuff is nice. Okay. So the next thing we are going to do is learn about signals. So signals are, I guess, similar to what you might do with, say, triggers or something like that in other games where whenever something happens to an object, it gives off a signal. And that doesn't necessarily mean that it's calling an API from another object or something like that. It's supposed to be looser coupled than that. It just radiates off the signal. And if there's anything else in the scene that's listening for that particular signal, it will hear the signal and be able to do something with it. So I think, as far as I know, the advantage of using signals instead of like an object API or something like that, or class functions and things, is you don't have to know anything about the other game objects, and nor do the other game objects have to call any functions that aren't inside themselves. So if we had, say, a signal that was like start something, and you called the function in the other object saying start, what you end up with is, if you wanted to rename it to initiate or something like that, you'd have to go to both objects and fix things. Or potentially that kind of, these ramifications might go across your whole scene. Whereas if you just give off a signal and then you don't care who's listening to it or not, it means you don't have to be as tightly coupled between things, which is very good in a game where a bunch of potentially random objects might have to have an interaction with each other in some way, but you don't know for certain. So I think that's why they use stuff like signals. I think I'm basically paraphrasing what they're probably going to say here. Yeah, nodes, mit, things. Okay. So, callable signals, first class type since Godot 4. So I think this means that they're a part of the standard API that you get in Godot. And this is an observer pattern, which is like a kind of basic design pattern for things listening to each other, I guess. Okay, so we're going to use a signal to make a Godot icon from the previous lesson that was listening to play input move and stop by pressing a button. Okay, GD script. They call it Pascal case. I wonder if that's because it was used in Pascal. I've always called it camel case. Wait, classes use Pascal case and variables and functions use snake case, and constants are all caps. I have not seen this kind of mix before, where you can signify certain types of objects by the way that you're doing case. But in a sense, that kind of works, because you can be like, if you see it in camel case, it's not an actual object, it's a class. So actually, I don't know. Is a variable instance of a class? Yeah, no. So the variable is in snake case, so that's an individual object. And then the class that defines the object type is in, I keep saying Pascal case, even though it's camel case to me. Yeah, that's kind of nice way. So you can, like, once you get used to it, you can intuitively look at things and you can go, no, that's the class. This other thing is the variable. Okay, scene setup. To add a button to our game, we'll create a new scene, which will include both the button and the Sprite 2D scene. So I think this is the Sprite 2D. TSCN is the script or the scene? No, that's the scene we created. Yeah, okay. So this is the scene, and we're going to create a new scene. I'm going to put this over here. Can I collapse this? No, I don't think I can. That's all right. I'll put it behind that anyway. Okay. Create a new scene. Scene menu, new scene. Oh yeah. So part of me is very Unity based, where I feel like creating a scene. Oh, Halogen, good point. Pascal case is different because Pascal has the first letter capitalized. So that's why it's not camel case. Very good. I did not notice that. I missed that. So that makes a lot of sense because classes usually have an initial capital. Oh, you're a bit behind. Oh, gee. Oh, gee. Okay. So I've created a new scene. The new scene is currently empty. Click the 2D scene button. This will add a node 2D as our root. So the root node is 2D scene. Then in the file system dot, click and drag the sprite file onto the node 2D. Okay, so sprite script goes on the node 2D. So now it's a sub scene of this scene and it goes into the hierarchy. We want to add another node as a sibling of Sprite 2D. Right click on node 2D and add a child. And this one's going to be a button. So they say you can just search for a button there, or you can also go through here and find it. Wait, control, base button, and button. Okay, so there's a button there. Okay, and they're saying in the viewport, so it'll be here in 2D, here's the button, and it is tiny, and they're like, you can click and drag to resize it, but I think I have to get closer to, okay. Zoom back out. How big is this? This is the screen. We can be a bit bigger than that. I think it doesn't matter. If there's only one button, we might as well make it big enough that we can really see it easily. Okay, click on the dragon to move itself closer to the sprite. We put it here. That's nice and aesthetic. You can also write a label on the button by editing its text property in the inspector. Enter toggle motion. Okay, inspector is up here. Wait. No, inspector's over here. Text. Toggle motion. Okay. Your scene tree and viewport should look like that. My button's in a different spot. Hopefully that's not a problem. Save the scene. And they're saying node 2D scene. Okay, node 2D scene. You can run it with F6, which is up here. I'll just press F6. And that hasn't done anything yet because the button is not actually emitting any signals, nor is the object listening for them, I assume. Here, when we connect the button pressed signal to our Sprite 2D, and we want to call a new function that will toggle its motion on and off. We need to have a script attached to the Sprite2D node, which we do from the previous lesson. Okay, you can connect signals in the node doc. Okay, is that the node doc? Okay, I should stop running this. I don't need to run that right now. Oh, node doc is there's a tab somewhere here. Doc displays a list of signals available on the selected node, and there's a pressed signal there. Double click that to open the node connection window. Can connect the signal to the Sprite2D node. The node needs a receiver method, a function that Godot will call when the button emits a signal. Editor generates one for you. That's nice. By convention, on node name, signal name. So on button pressed. So we connect that and it creates the function for us on button pressed. They're not quite as loosely coupled as I thought. The nice thing though is the button doesn't have to know what this function name is. So there is some loose coupling there. The button just goes, I got pressed. And then this thing is the thing that's listening and it needs to know that a certain thing has happened. Okay, so when connecting signals via the editor's node doc, you can use two modes. So the simple one, we connect the node, and this creates the callback function, which we've got here. If you're using an external editor, the automatic code red generation might not work. Okay. So, complete the signal, create the thing. If you click the icon, a window pops up and displays information about the connection. So this is the thing that's saying there's an external connection, and it says it's coming from this thing called button. And the press signal targets the Sprite2D, which is Sprite2D is the script I think that we're in right now. Yeah. Okay, so the pass keyword says don't do anything in this function, and we're going to replace that with some actual code. So Sprite2D moves thanks to code in the process function. Godot provides a method to toggle processing on and off. Ah, cool. So set process says whether it's actually going to run this processing or not. So I guess this is like, is the object active or not active? So on button press, instead of the pass, we're going to set process. Oh, you have to spell it right if we want autocomplete. And it's going to be the inverse of whether it's currently processing right now. So basically it's just going to flip it. So toggles processing on and off. Icons motion on and off on processing the button. Before trying the game, we need to simplify our process function to move the node automatically and not wait for user input. Replace it with the following code, which we saw 2 lessons ago. Okay, so previously, instead of with user input, this thing was just automatically spinning around in a circle. And I think that's what we're bringing back now. I can't remember what the block quotes are for, oh, I wonder if I can just... There's no way to comment a section in this. I can't even remember what the comment is. Is it a no? All right, I'm gonna look this up because I think it's something I'm gonna want to know later. Marc several lines has commented once in Godot 4 years ago. Well, I hope they're using the same scripting language. Oh, highlighting some lines and pressing Shift hash. Control K. Oh, there you go. Yeah. Ooh. Ugly, but it worked. It put the hashes right up against the text. I would kind of prefer them to be in a column down the side so you can see more clearly which is commented or not. But that's okay. It's easier than having to type it all out myself. Okay, so what we've got now is automatic movement, and the movement turns on and off when the button is pressed. And it's saying your code should look like this. Mine does, but I saved my old code in there for the moment. Okay, so we're going to run this, see how it goes. So it's moving. I toggle motion and it stops processing. And I toggle again, it starts processing. So that's nice. And you can see that because you can see when I press the button. Okay, so we have signals. What else are we going to learn? Connecting a signal via code. You can connect signals via code instead of using the editor. This is necessary when you create nodes or instantiate scenes inside of a script. Also, if we're going to create nodes or scenes on the fly, let's use a different node. Godot has a timer node that's useful to implement skill cooldown times, weapon reloading, and more. So anything that's supposed to take a specific amount of time, I guess. Okay, so back to the 2D workspace. Click the 2D text at the top of the window or press Control F1. Which thing? 2D text at the top of the window. Oh, right. The same way I've already done. Okay. How you get there is click the 2D text. I thought there was some other 2D thing. Okay, in the scene dock, right click on Sprite 2D node and add a new child node. And we're going to add a timer. Okay, there's a timer now. With the timer selected, go to the inspector and enable auto start. Auto start. Click the script icon next to the Sprite 2D. Script is that? Nope, that was scene. Ooh, where am I now? Script, okay. I now can't see the other nodes, which is strange. What did I just do a second ago? I'm undoing. I can't see the other nodes in the scene anymore. Oh, wait, because I'm not in the scene now. Right. Because I went into that node, into that scene, and so I couldn't see this whole organizational structure, I guess. That must be what I just did. Open in editor opens this one node. Okay. I'm not really sure how to get back from that, other than, like, selecting it explicitly from here. So, we'll see. That's probably just me needing to learn the interface. Okay. So we've jumped back to the script by opening the Sprite 2D script, which is this one. It's weird that this... Oh, that's what I did. Okay, so this is in the script. This is in Node 2D. It's a bit strange that this is like selecting the different objects and it changes everything. And it makes me feel like it would only change things in this panel, but I guess it's just a matter of getting used to how you navigate. Okay. So, we need to do 2 operations to connect nodes via code. Get a reference to the timer from Sprite 2D and call the connect method on the timer's timeout signal. So, connect method of the signal you want to listen to. In this case, we listen to the timer's timeout signal. Okay, we want to connect that signal when the scene is instantiated. We can do that using the node ready. built-in function, which is called automatically by the engine when a node is fully instantiated. I was thinking of something funny, actually, Halogen, because you were saying before that you had an assignment due tomorrow night. It would be really funny if we worked on it here. Although it's the wrong kind of funny, because you get like, that's probably academic misconduct. You get an ex-lecturer to work on your assignment for you. So maybe we won't. But it would have been funny. Work on an assignment in a group while publicly streaming. I'm sure people actually have done that before, though. Okay. So, to get a reference to a node relative to the current one, we use the method node.getNode, and then you refer to them by name, I guess. We can store the reference in a variable. Okay. So in this script, so getNode will look at the children here, and that makes sense because timer is one of the children. If you rename the timer node to blinking timer, you would have to change the call because this is specifically this. Okay. So we have our ready function, which I assume is something that happens at the beginning of processing. And so we have a timer variable that is our get the node called, oh, look at that. It knows, oh, did I not? There we go. I didn't autocomplete properly. Okay, so it knows what other scenes are attached to this one, or specifically hierarchically below this one, and auto-completed to that. Okay, so it looks at the children, and gets their nodes by name. So we now connect the timer in the ready function, which means for the rest of this, we have a variable timer that we can use. Connect the timer's timeout signal to the node to which a script is attached. So there's the timer, and we're saying timer dot. I hope that's. I don't know if that autocomplete is working. No, it totally isn't. We'll find out if that's a problem later. Connect. So we connect the node when the timer. Right. What is it saying here? We connect the timer's timeout signal to the node to which this script is attached, which is the Sprite 2D node. When the timer emits timeout, so when the timer emits timeout, we are going to call the function on timer timeout. I don't entirely understand when they have an underscore in front of them, but maybe that's the underscore at the beginning of it says this is a local function. But no, these are as well. Who knows? I think if when I start actually making stuff, I'm gonna end up with a different style guide by accident, because I haven't really figured out which things should have underscores and which shouldn't. I'm guessing maybe that all functions have an underscore at the beginning, whereas all variables don't. But who knows? Okay. So this is going to toggle the sprite's visibility on a timer. Oh. By convention, we call callback methods as underscore this, and in C# as camel case. Oh no, that's Pascal case. I learned something. Here it'll be on time and timeout for GD script, and yep, okay. So now we create the actual callback function. On time and timeout. And they're saying, right, visible equals not visible. I don't have a visible variable yet. I wonder if I even need one. It appears that I don't need one looking at the finished script there. So visible must be a Godot standard something or other. I keep forgetting what they actually call them. They're first class things. So this is probably a first class thing for whether you render something or not. And it appears to, ooh, another semicolon. We need a little count of how many semicolons that I put into my code. Either semicolons or curly brackets, things that I don't actually need. Okay, so the timer is going to toggle visibility. Okay, and now we're going to define the signal itself, I think. Yeah, surely a little counter in the OBS layout. Yeah, I should add something. Should I do it now? No, I won't do it now. Is it easy to do it in OBS? I'm just trying something. Is that coming up? I think it's probably coming up. It's huge. Where's the font size? Wait, where's the font size? Oh, I don't think it does font size. I think it just does. You scale it yourself. Yeah. It's very big, isn't it? Okay. So for the evening, we have... Oh, I'm gonna... There you go. Put that there. And that is the number of times I have done a semicolon or a bracket mistake while coding. I don't know if there's an easy way to increment that, or I'm just gonna have to edit it every time it comes up. But that's my fault for putting the semicolons in my code. Okay, so toggles visibility. And then we're learning about you can make custom signals. So in a script attached to an object, you can make custom signals happen. As signals represent events that just occurred, we generally use an action verb in the past tense in their names. Good to know. Yeah, that does make sense. Your signals work the same way as the built-in ones. They appear in the node tab and you can connect to them like any other. To emit a signal in your scripts, call emit on the signal. All right, so we have to create a signal and then call emit on it. So for example, they're saying here, you can take damage, and if health is less than or equal to 0, emit the health depleted signal. I assume health depleted needs to have been defined. Yeah, signal health depleted. Okay. It can say more than one thing. So health changed, old value, new value. That's handy. So you can package, like it's a little packet you can put in your script, in your signals to send out. We didn't connect this. Oh, maybe that's it. If we run it now, the sprite should blink on and off at 1 second intervals. I didn't set the timer to be a 1 sec. Oh, wait, here it is. 1 second timer. Okay. So it defaults to a 1 second timer. Right. So 1 second on, 1 second off. 1 second on, 1 second off. And that actually is very close to being. I think it's exactly 50% of the rotation by the looks of it. Because the rotational speed is pi, and 2 pi for a full circle. So we're only ever seeing the top half of the circle here, because it's exactly 1 second. Okay, I skipped over things, and I thought we were going to write more code for the for the emitting of the signal. But this timer was emitting the signal, the timer finished every 1 full second. Okay, cool. All right. And I can still stop the motion. That doesn't stop the flashing. It's actually kind of easier to see the flashing when it's not moving. Okay, good. So we now have the ability to work with objects, take user input, and emit signals from objects that other objects can receive. I should be calling these things scenes, I guess. Scenes emit signals, and other scenes can receive those signals. So I'm learning kind of everything. And in the next section, which is called Your First 2D Game, you'll create a complete 2D game and put everything you learned so far into practice. This is good, because this is where I want to be. Once I finish the you have made a 2D game, then it'll be a you make your own 2D game, and then we get to the complicated matter of actually trying to do things that aren't just kind of following what someone else is telling me how to do. Okay, so we've done that, and we're on to your first 2D game. Step-by-step tutorial series, you create your first complete 2D game with Godot. By the end of the series, you will have a simple yet complete game of your own, like the image below. So it looks like it's like a little survivors game, but without the shooting. You're just moving around and trying not to touch the enemies. Okay. When you think about it, we could have started here. I don't know how many months ago when I started looking at Godot, but I could have started here, and it probably would have been okay. But you know, it's been fun going through the process, and also potentially like going through and like trying to help them out with how they were structuring their GD script tutorials. So it's been fun, and I think um not too worried about the time this takes as well. So I'm not too worried about being efficient and things. I think it's just more to have fun and do it. Okay. The game is called Dodge the Creeps. Your character must move and avoid the enemies for as long as possible. Learn to create a complete 2D game. Structure a simple game project. Well, that's actually good to be able to structure it, because I don't know how they usually structure things. Move the player character, change its sprite, spawn random enemies, and count the score, and more. And there's another series afterwards where you create a similar game but in 3D. We probably won't do that. Or maybe we will. Who knows? It depends how confident I think I am to make stuff afterwards. Okay, so why are we starting with 2D? If you're new to game development or unfamiliar with Godot, we recommend starting with 2D games. Yeah, I guess you don't have to think about as much stuff in 2D games. So, find a completed version of this project at this location. Let's not look at the completed one. I think it might be better to go through the tutorial, learn about it, and then see the difference between mine and the completed one elsewhere. Okay, prerequisites. Intended for beginners who followed the complete step-by-step. I did. And I am a beginner to Godot, so that counts. If you're an experienced programmer, you can find the complete demo source code here. Well, I am an experienced programmer, so let's go through it anyway, and I'll have a look at that later. Prepared some game assets you'll need to download, so we can jump straight into the code. Okay, let's download some assets. I'll put that over there. Don't need that on the main screen. All right, setting up the project. We'll set up an organized project. Launch Godot, create a new project. Project. I assume quit to project list is going to close the current project. Yes. Create a new project. Only need to choose the valid project path. Other default settings alone. Documents, new game project. What's this one? It's like first 2D game. Okay, we create a folder in user documents. That's fine. That's where my stuff will be anyway. Leave default settings, so don't change any of this stuff. What, it automatically uses Git? I don't think I have logged into Git via Godot, so it's probably unlikely that it's going to do that. Okay, here's my new project. I'm just going to shrink that, put it over here for now. Hey, Mitchell, how's it going? I am not side questing today. I am actually working on things. So I finished part of the tutorial and am now going into the create your first 2D game in Godot tutorial. We've also got a brand new feature in the stream, which is the count of how many times I tried to put a semicolon or curly brackets in Godot script, which doesn't use those symbols at all. So how many times do I instinctively use C or C++? Which is kind of fun when you think about it, because I'm working in a language that I just learnt, but my sort of native programming language I have used for, where are we now? 25, at least 25 years. So like that's the habits that I'm trying to fight against. We'll see how we go. And also the text, this is just purely a text field in OBS. So I've got to go in and manually edit it every time this happens because I don't have any automation. So that'll make it even more annoying every time I do it. And that's going to help teach me to stop doing it. Okay, so we've downloaded this. Extract the archive and move the art and fonts directories to your projects directory. Okay. So I've just got these on the other monitor, so don't worry, I'm just gonna move some files around. First 2D game. Actually, I can bring that here so you can just see what I'm doing. And we've got art and fonts, and we're just copying them into this folder. Hopefully that's in the right spot. We'll see. Yep, there you go. Art and fonts appeared here. Very good. So now we have our art assets. And that's how easy it is to make art assets for games. You download the ones. We will find out at some point during this project the difficulty of creating and wrangling art assets. We'll see that later, I assume. I feel like that's like one of those sticking points that you 100% know is going to be a problem when you're a programmer and you don't really know how to make digital art, and you know that that's something that's coming. You know, it's like just like you can see it off in the distance. So it's like the Titanic looking at the iceberg and going, yeah, that thing's going to slow us down considerably. Okay, so your project should look like this. I think that's fine. Icon.svg is at the same level as art and fonts. You with 3JS, Mitchell? Wait, 3JS? I don't even remember what that is. Wait. Or is that what this is? No. That is so not. 3JS plus Z is some kind of real estate thing. JavaScript 3D. Ah, I see. Lets you code assets as well. Interesting. That reminds me of, has anyone played around with the shader toy? Shader toy is like one of the funnest things where you just like basically coding directly in OpenGL shaders. And I've seen some hilarious things that people do there. It's like, you're making OpenGL shaders, but what you're actually doing is, what was I gonna say? Your people make geometry and all this kind of stuff. Like I saw someone re-implement the first level of Mario in a shader, and I'm just like, that is so much effort. But also I applaud it. But so much effort. Mitchell said, look at the website. Wait. Was that the 3JS one that I looked at? Is this actually something that's made in 3JS? Oh, that's the point of this, is just like, this is a demo for someone. Oh no, not this one. Not this one, yeah, right. Because this one was like, what is this? No, this is definitely real estate. Oh, right. So they've got examples of things that people have done in 3JS here. What's this? Oh, that's very cute. Oh. So does that mean 3JS is basically a game engine? Or people are just doing a lot of stuff manually? Oh wow, is this like an educational thing about how to this is like some finance education thing. Smart spending for the person that just bought a new OLED monitor. I need advice on smarter spending. So it's all JS or React. If they use React 3 Fiber. I don't actually know what that is, but I assume it's the stuff that allows you to go into 3D. Oh, interesting. Choosing the things you care most about. Oh, maybe this smart spending is about giving to charity, because this is like all very positive things. Let's go environment. Fintechs that suit you the best. Oh. Ha ha ha! It is like a mini game engine. Oh, and you can look around. Okay, I'm getting distracted here. I don't need to do this. But thank you for digital banking 3D demo. So there's heaps of stuff here. One of your favorite websites is done by Bruno Simon, who is like the 3JS guy. Right. I assume it's probably in here somewhere. Anyway, let's go back to Godot for now. But it was nice to look at it. It's always really interesting seeing how many different kind of coding environments there are in the world that people can use for things. I could search. I'm not going to much. I'm about to jump in there and go and look at it, but I'm just like, okay, we're gonna come back here and at least finish setting up this project. Okay. Project is designed for portrait modes. We need to adjust the size of the game window. Click on project settings. Display window. Width 480. And height 720. That's like a phone window. Did that change anything? This thing still doesn't quite look like that. Wait, did I not save that? No, there's no, that's fine. I'll just leave it. Also, oh, I wasn't finished. Where was it? I should have read what it was. What was it? Under, oh, it's here. Stretch. Canvas items. An aspect to keep. Shows that the game scales consistently on different size screens. Okay. Oh, now it's changed. I could probably zoom in on the actual screen. So it's actually got pixels up here. 250, 500. And that's 0 down to 750-ish there. Mitchell's, to be honest, I think I instigate a ton of the side questing on these streams. You have indeed instigated some side questing. Okay. Organizing project, we made 3 independent scenes, a player, a mob, and a HUD, which we will combine into the game's main scene. So I assume we're going to create a main scene first. In a larger project, it might be useful to create folders to hold various scenes. Yeah, sure, that makes sense. But this relatively small game, you can save your scenes and scripts in the root folder identified by res. So this res is the shortcut to the folder that was in my documents. You can see your project folders in the file system dock in the lower left corner. Yes, yeah, here. With the project in place, we're ready to design the player scene in the next lesson. Okay, with the project scenes in place, we can start working on the player-controlled character. First scene will define the player object. One of the benefits of creating a separate player scene is that we can test it separately even before we've created other parts of the game. That's nice, actually. I think that's nice to have that kind of, what's the word? Encapsulation? Is it encapsulation? Or just like objects separate from each other. It's so weird how, like, as I kind of move around between being a full-on programmer into like this kind of like, nowadays I'm in like comms and operations and stuff like that, I find that I have lost a lot of the keywords that would have come naturally to me before when I was just purely talking technical code all the time. I'm pretty sure the word for like intelligently separating objects is one that I knew very well, but I can't remember it right now. Anyway, okay, node structure. To begin, we need to choose a root node for the player object. As a general rule, a scene's root node should reflect the object's desired functionality, what the object is. In the upper left corner, in the scene tab, click the other and add an area 2D node to the scene. Lots of options here. All right, I'm gonna look up area 2D. Okay, so there's an area 2D node. I'm assuming that means it's a 2D shape with a certain amount of space in it. Okay, when I add the area 2D node, Godot will display the following warning icon next to it in the scene tree. Warning. Node has no shape, so it can't collide or interact. Oh, so area 2D is meant to be a thing that can do collisions and trigger interactions with other objects based on overlaps. Consider adding a collision shape or collision polygon as a child to define its shape. Okay. We'll ignore that warning temporarily because we first set up player's visuals using an animated sprite. Ah, this is good because the idea of animated sprites is something that I'm going to want to learn for putting random things in my little chicken restaurant. Once the visuals are ready, we'll add a collision shape as a child node. This will allow us to accurately size and position the shape based on the sprite's appearance. With the area 2D, we can detect objects that overlap or run into the player. Yeah, that's what I was thinking. So this is like a physics object, I guess. Change the node's name to player by double-clicking on it. We can add additional nodes to give more functionality, but before we add any children, we want to make sure we don't accidentally move or resize them by clicking on them. Select the node and click the icon, and then to the right of the lock, group selected nodes. Tooltip says groups the selected node with its children. This causes the parent to be selected when any child node is clicked in 2D and 3D view. Right. That makes sense. We don't want the object. We don't want to be able to pull the sprite away from the physics object. How do you tell whether that's on or off? Oh, I guess there's a little sign, a little symbol there on it. Save this scene. So scene save or just Control S. Oh. As player.scene. Okay, good. I already forgot what TSCN means, but I assume something scene. T-scene. Okay, we'll be following Godot naming conventions. Yeah, okay, we looked at those before. Sprite animation. Click on the player node and add a child node animated sprite 2D. So they say Control A, or I assume I can just right click on it as well. Yep, okay. Animated sprite 2D. It's very interesting when you look at these and you're like, I don't know how I'd find these without a search. Oh wait, the search is still there in area. That's why. Right, so there's animation mixer. It's nice to see what all the kind of stuff is here. I actually don't know where I would find that. Okay, canvas item. Node 2D. Animated sprite. Oh, okay, so it was logical. I went blindly into it, looking at it, and I did find it. So animated sprite 2D will handle the appearance and animations for our player. There's a warning symbol next to that node. Animated sprite 2D requires sprite frames resource, which is the list of the animations it can display. Make sure animated sprite 2D is selected, and then find the sprite frames property under the animation inspector. Animation, sprite frames, there you go. Animation section in the inspector and click empty new sprite frames. Okay, so now we've created some sprite frames. We don't know what actually that means yet, but I assume it's going to be like you can put a bunch of sprites in. Click on the sprite frames you just created to open the sprite frames panel. All right, that's down here. On the left is a list of animations. Click the default one and rename it to walk. Oh, okay, so this is going to be what the animation plays while it's walking. So this is how you do like walk cycles, jump cycles, and stuff like that. Click the add animation button to create a second animation named up. Where's the add animation button? I assume it's that. Yep. This one's called up. Find the player images in the file system doc. They're in the art folder. Drag the two images for each animation into the animation frames side of the panel for the corresponding animation. Okay, player, gray, walk 1. Okay, walk animation. And walk 2. And then up 1 and ooh, no. Sprite frames. Okay, we've got the 2 in the walk. I'm not sure why that oh, I dragged it into the scene by accident, didn't I? Is that going to come back and haunt me? That random PNG that I may have. Oh, no, that's the walk cycle. Okay, that's fine. That's fine. We're okay. It'd be funny though if I had just dragged it into the scene there and I just dumped an object in there. But I think it's okay. I think it's this linking into there because when I change it, it changes to its own sprites. So it's good. It's good. It'll just jump scare me in the game. Yeah, at some point it's like bang, it just pops up and it's like the size of the screen. Should be okay though. Okay, so up has 2 animations and walk has 2. So it looks like one of them's horizontal and one of them's vertical. The only thing that's different is that little eye and where it's looking. Okay, player images are a bit too large for the game window, so we need to scale them down. Click on the animated sprite 2D node and set the scale property to half. Okay, scale will be in transform. They're locked together, so I expect they'll both change. Yeah, good. Finally, add a collision shape 2D as a child of player. This is all coming back to me now, that when you create an object in a game, you've got to have how it looks visually and then how it acts in interaction with the physics with our other objects. So this kind of makes perfect sense. So these are the 2 children of that. This character, capsule shape 2D node gives us best fit. So next to shape in the inspector, click empty, new capsule shape 2D. Resize the shape to cover the sprite. Okay, let's get closer here. This is funny. This is me like trying to figure out the controls, because I'm like, when do I press control or shift to do things? Okay, this object. Oh, no. Oh, you know the funny thing about this? I set this group selected nodes, which means that anytime I select the collision shape as a child of the player, it's going to select the whole player. Yeah. So I need to ungroup that so that I can, so I can play around with this capsule. That's not what I was expecting the capsule to do. Okay, put that back in the center of the object. That's interesting. That's roughly correct, right? That's about the right shape. When you're finished, your player scene should look like this. Player, animated sprite, 2D, collision shape, 2D. Okay, I'm going to select player. Reset the transformation, reload the scene to remove this warning. Oh, I've moved it at some point. That didn't particularly change it, but that's fine. Reload scene. How do I reload the scene? Reload. I'm just going to leave it. It's fine. Okay, that's locked. Children not selectable. Yep. Once this is done, the warning on the Area 2D node will disappear as it now has a shape assigned and can interact with other objects. Okay, so once I've grouped them together, I'm not getting a warning because the player and its sprite and interaction box are all together as a single object. Save scene. Okay, next we'll add a script to move and animate it, and I assume it's going to be very similar to the script we did previously. Okay, player, and we're going to add script. Attach script? Yes, attach script. Default settings are fine, they say. And just click create. Okay, here is my script file. Start by declaring the member variables this object would need. So it extends area 2D. And we are using this export here. So I wonder if export means that we are publicizing something so that other things can change it. It says here, actually. Using the export keyword in the first variable speed allows us to set its value in the inspector. Oh, so that means it's going to have a setup here for us to be able to like play around with, which is good. Okay, export variable speed is 400. They've got a comment there. I'm going to leave it out. I think speed is well named enough. It probably won't need it. Variable screen size. I get freaked out, I think, in loosely typed languages when I see something called variable screen size. I'm just like, what? What is that? Because you can't do that with a single value, but it's probably going to be a vector 2, I assume. But like, it's just funny when it doesn't have anything yet. Okay. Warning, if you're using C#, no, that's fine. Not using C#. Rebuild project assemblies when you want to do, okay, that's fine. Click on the player node, you'll see property now appears in the inspector. Okay, so I should save this first. Player node inspector speed. Beautiful. So we've exported that variable, and so now we can change the player speed if we need to. Your player script should contain a ready and a process. Yes. If you didn't select default, create these functions. No, that's good. Okay, on ready, we are going to... Oh, we don't have pass. We're going to instantiate screen size to this thing saying get viewport rectangle dot size. And now we can use a process function to define what the player will do. Process called every frame. This is the update loop. We use it to update elements of our game, which we expect will change often. For the player, excuse me. I think I'm a little bit tired this evening, but it's all good. Process, check for input, move in the given direction, and play the appropriate animation. So very, very standard game controller. Halogen saying new ones count for when you say untyped instead of dynamically typed. This is a joke, just being a nerd. Oh. Wait, which bit were we talking about then? I have lost the context. I don't know. Oh, are you talking about the count of the semicolon bracket count is also when I make mistakes of saying something is untyped when it's not actually untyped. It's dynamically typed, which is different. Okay, yes. I love it. We should put over here, there's this whole massive column of like Marc doesn't sound like a real programmer because of XYZ and all the things that I've done along the way. We'll just keep this like running tally of all the random mistakes that I've made. Okay, I'm gonna get back to this before I get caught up in a complete side quest stream where all I do is OBS overlay stuff. Although I think that could be funny if we do that at some point. It's probably one of the best things about OBS is that you can literally modify it on the fly. And it will do it like what I did earlier, where just adding a semicolon bracket count like that. It's actually cool having that on my other screen over there, so I can see it when I go look at chat and stuff like that. Has stopped me several times from just automatically putting there was so close to being a semicolon at the end of this line, by the way. But I looked over there and was like, no, don't add to the count, because then you got to go into OBS and edit the text field and stuff. Okay. All right. Process. The process is going to do this. So the first thing is check for input. Is the player pressing a key? We have 4 directional inputs. So this is going to be really similar to the last time we did that, but it looks like... Oh, we're going to set up input first, though. Input actions are defined in the project settings under input map. Project settings. Did I scroll past it? I definitely scrolled past it. Input devices? Ooh, accelerometer. That's pretty cool. Okay, okay. Don't get sidetracked. Hmm. I'll have to find that. Project settings. Input map tab. Oh, it's at the top. It's a tab. It's not in the general settings. It has its own space. That makes sense. Type move right in the top bar and click the add button to add the move right action. So add new action here. Move right. That goes on and enter. That's good. Are we going to add all the other actions as well? Need to assign a key to this action. Plus icon will open the event manager window. The listening for input field should be automatically selected. Yes. Plus the right key on your keyboard in the menu should look like... Oh! Cool. So when you're setting up input, you literally press the input on your own computer, and then it deals with that. Okay, right key is now associated with the move right. I wonder if that's as good as previously, where it was able to just go across to the gamepad and still work. We'll see. Okay, we're gonna add move left to left, move up to up, and down to down. Okay. Move left. This is actually very very nice and easy to do this. You just go here and then press the button that you want. I guess the only annoying thing is if I want to map it to more than one button, but it looks like you could probably add more than one button there. But this is this just seems like a very nice way to do it. Now this is set up in the project, and so this is the input for the project. So you could map all your different inputs here to individual buttons and stuff like that, which is like, this is a nice way to do it. Input map should look like this. Move right, left, up, down. They did down, up, but order is not important here. There's a dead zone, which is different, but I assume that that will be okay because I don't know exactly how they're calculating dead zones for controllers anyway. All right. Note, we only mapped one key to each input action, but you can map multiple keys, joystick buttons, or mouse buttons to the same input action. Okay, good, good. You can detect whether a key is pressed using input is action pressed, which returns true if it's pressed or false if it isn't. Okay, so process. We have a velocity. And that's going to be a 2D vector. And they're saying use the 0 vector. So at the start of the process, we say that we're not moving. So that means we're not carrying over any inertia from the previous turn. So then we go through. You know, this is the kind of place where I would usually put a switch statement, because switch statements work really nicely for like input mapping and stuff like that. But I actually feel like switch statements have sort of gone out of fashion and we're not really using them anymore these days. Is action pressed? Ah, and these things have autocomplete in here because we put them in the input mapping. So right, left, up, down. And if it's right, then the X value of the velocity goes up by 1. And now I'm going to copy paste this. Oops. All right, now we've got 4 of them. And I just change the bits that I need. Do we have a minus equals? We do. I mean, I could do minus equals, or I could do plus equals -1. It would do the same thing. move up, and a move down. Okay, and these are both in the Y direction. Up would be negative, and down is positive. I'm assuming we're counting from the top left corner. In fact, we know, because the Y is... Let me just zoom out. The Y is 0, and it's counting positively as it goes downwards. Go back to my script. We've got some animation in here as well. So this is saying if the velocity's length, so the length of the vector, Halogen's going to focus. Thank you for coming along, and good luck with the assignment as well. Hope it goes well. So we're testing the length of the vector, and if it's greater than 0, that means we're moving. I'm just going to put this in here. Maybe see you next week, depending on how busy you are with other things. Okay, velocity is greater than 0, we're moving. Then velocity is, we're going to normalize it. So if you recall, normalizing a vector makes it length 1. So I think this is the kind of thing so that if we press up and left, for example, we don't end up with the strafe jumping issue. So if you remember, this is really, really old school game programming lore. But in, was it Doom or Quake? I think it may have been Quake 1, but it could have been Doom. When you moved diagonally, it would just add the 2 vectors together. But if you look at 2 vectors and the corresponding diagonal, if that forms a square, the corresponding diagonal is actually longer than the other 2 vectors. So when you're moving diagonally, if you set that vector in a particular way, you would go 1 point, I think it's 1.4, the hypotenuse of a right-angled unit triangle. About 1.4, you would then multiply your current speed by 1.4. And if you changed your diagonal on the point where you landed on the ground and jumped again, you would multiply it again. And you could keep multiplying it if you got the timing perfect on this in this particular bug. And that's how we got strafe jumping, which was then years later renamed to bee hopping and stuff. And then you got like the kind of speedrunning techniques for old school first person shooters. And it got to a point where they were just like, well, you know what, we're going to leave this in the game because it's so cool and it takes just enough skill that people are going to really enjoy doing this. And so what we're doing in this game here is we're removing the possibility of that happening. So we're going to normalize that, which makes it a length 1 vector no matter what, multiplied by that by speed. So we'll always be going exactly at our speed variable rather than having the chance to accelerate. So if I take out this and say the velocity, or if I take out the normalized bit and I say just velocity multiplied by speed, diagonally we'll move faster than if we were going straight. Yeah, Mitchell, it's like an intended feature. So it ended up being something that like set off this whole like kind of part of the boomer shooter genre and stuff like that is based on that kind of thing and like movement tech. And you think about all of the stuff in first person shooters that have come forward nowadays about like skill based movement, you could say it all came from that originally, because it was hard to actually make that work. So it's very cool. All right, and we have a thing here which I have not learnt anything about yet. No, I don't think so, but it's like animated sprite 2D play. So $ animated sprite 2D dot play. And then we've got an else. else we stop. So I guess the animations that we had before. Oh, I'm not in the thing that has the animations right now. But Animated Sprite 2D has those animations, and they're gonna run if you're moving, and then they're gonna stop animating if you're not moving. But I assume we're going to be taught about this. Oh yeah, and they're talking about vector math here and stuff. Check where the player's moves so we can call play or stop on the animated sprite. Now that we have a movement direction, we can update the player's position. We can also use clamp to prevent it from leaving the screen. Well, that's good. Oh, that's why we have screen size. It's interesting that that's in the player, but I guess in a simple enough game, you can just say to the player that they can't leave. And they're governing it themselves. Like most of the time, it's the world itself that tells the player where it can and can't go, not the player getting to decide. Okay. So in the process, we have done the animation stuff, and we go, okay. Position, wait, do we have a position? No, it has a position variable, so we can change the position variable. Velocity times delta, so delta is up here. Float, it's in seconds, and that's a fraction of the velocity. So that means we can move 400 pixels a second. And then position clamp. So there's a min vector and a max vector, which means it's going to be the top left. Wait, where's my camera? Top left and bottom right. I should not look at my inverted camera when I'm doing stuff with my hands, because then I'm just like, where am I pressing? Okay, top left and bottom right. So the top left is going to be 0. Oh, I just clicked on that, and it. All right, no, it's fine. Vector 2, 0 is the top left, and the bottom right is screen size, because screen size is a vector 2. Okay. Let's explore the area ahead of us later. Yeah. I remember playing World of Warcraft, and there was a passage that went nowhere that you couldn't walk down. It was an invisible wall. And there was an NPC standing there. And their name was Addon. And they said that you couldn't go there until they'd finished doing something. And it was like a really funny way to have, like, in the game a thing saying that when we make an add-on, it'll be through this pathway. So it was kind of cool. I think the first time you discover it, you're like, what? And it's like the developers are breaking the fourth wall and telling you that there's going to be a thing there later, but it's not there yet. Okay, so we can run the current scene, and we should be able to control... Wait, where did that go? Let's see what we have done wrong. Cannot find member 0 in base vector. Oh, right. It's a it's like a hash define. Oh, it's a constant, sorry, so it should be all caps. The Pokemon ones, they're also random, like a bunch of Psyduck just chilling, not wanting to move. They get in your way. Or someone's hungry and you have to get them candy. I actually played that recently where the Snorlaxes were blocking particular areas, and you had to, like, you had to get a particular object to be able to wake up the Snorlaxes. And the bonus is that when you wake up the Snorlax, they're angry. So immediately upon waking up the Snorlax, if you do the fight right, you can also get yourself a Snorlax to use in your party. So not only did they unlock the path, but they gave you another Pokemon in the same moment. Okay. Ha! Look at that! A little person with its little walking animation. It's so interesting how good game engines are now at just kind of helping you do things without needing you to actually do that much. In Pokemon, the old man is just asleep on the floor. I don't remember that bit. I remember the other ones where well, it was the same as the person was hungry. That was the guards that were thirsty, and until you gave them a cup of tea, they wouldn't let you progress to the next area. Funniest way to slow people down. Okay, choosing animations. Now the player can move, we need to change which animation is playing based on its direction. So we have a walk animation, walking to the right. Animation should be flipped horizontally for the left movement. We also have the up, which should be flipped vertically. Ah, okay. So, in the process function, so we've got the play and stop here. You know what I'm going to do? I'm going to put this in here so all of our sprite animation stuff is together and then our actual position stuff is there. So if they're saying velocity x is not equal to 0, so we're moving in some way horizontally. Animated sprite 2D. Oh. I thought that would, Oh, it auto-completes after I finish typing it. Thanks. Is walk. And then animated sprite 2D flip vertical is equal to false. Oh, right. So that means we're not going to flip it vertically in case we were for one of the other ones. And animated sprite 2D flip horizontal, we are potentially going to change this equals, all right, so we're testing the velocity's x component. So if it, oh, hang on, where is it? There is my second semicolon. I saw that as I was pressing it. I saw my finger go to the button and my brain said stop, but it was too late. Like, I actually thought in my head, like, don't press that semicolon. You don't need it, but my finger had already hit it. It was like, I actually knew as I was doing it that I was like, don't press that. You don't need to press that. Anyway, because I was already thinking about the Boolean stuff. So, if it's less than 0, you flip. So if we're going to the left, you flip it. And otherwise, we're going to the right, you don't flip it. Okay, and then else if the velocity's y is not 0, then the animation sprite 2D, I keep trying to autocomplete that one and it keeps not autocompleting, which is very strange. We use the up animation. And then the vertical flip is equal to the velocity dot y less than 0. So same kind of thing. Oh no, it won't be less than 0 this time. It'll be greater than 0 because if it's less than 0, you're going upwards. Yeah, so you don't flip it if you're going upwards. If you're going downwards, which is positive direction, then you'll flip. Okay, so this does the different animations. Boolean assignments in the code above are common shorthand for programmers. since we're doing a comparison test and also assigning a Boolean value, we can do both at the same time. Yeah, makes sense. Yeah, because if we wanted to, we could test this, create a Boolean variable, and assign it to this, but, you know, it's quicker and easier like that. Okay. Play the scene again and check animations. Good idea. Okay, so left, right, that's working. Up, down. I guess the up and down is kind of funny because this way it's walking like its feet are on the ground. But then when you go up or down, it's kind of swimming. So it's like, is this top down or is it side on? It's both, depending on which way you're moving. So the sprites are very strange, but you know, let's let it go. At least we know that this is working correctly because you can see the eye in the middle is going roughly in the right direction. But yeah, the side to side is 2D and then the up and down is top down. So this is just some kind, yeah, right, Mitchell, like it shouldn't flip. if there's gravity in this thing, it shouldn't flip. Or if this is top down, then it should the left and right should actually be like have its, like they're not legs, they're like the fins on a fish, like they are here. Should be doing the same animation but side to side. Anyway, let's not pick at it too hard. I think it's good and it's effectively teaching the subject matter anyway. Even if we can pick at it and go, that's not entirely correct. Anyway. Okay. When you're sure the movement is working correctly, add this line to ready so the player will be hidden when the game starts. Okay, so we're hiding the player when the game starts. All right, preparing for collisions. We want player to detect when it's hit by an enemy, but we haven't made any enemies yet. That's okay, because we're going to use the signal function. This is the nice thing about signal. You don't have to have the other bit of code to make it work. Mitch, maybe it's some sort of birdfish thing. Yes. It's some sort of creature, and sometimes it walks, and at other times it swims, I guess. Through the same substance. Let's just, it can be whatever it wants to be. Okay. Add the following at the top of the script. If you're using GD script after the extends. So we have a variable called a signal. Well, it's a signal, not a variable. A signal called hit. And defines a custom signal that we will have our player emit when it collides with an enemy. Oh, this is really interesting that the player is responsible for everything. So keeping yourself in the window and whether you hit something. Oh, actually, you know what? I didn't actually check that. Oh, wait, I'm hidden. One sec. Right, that's working. I'm trying to walk outside the thing, and because the coordinate, the sort of anchor coordinate for the player is the center, it never allows me to fully leave the area. That's good. Okay. Go back to being hidden, because I assume there's something that's going to make us appear at some point. Okay, so we have a hit, which is the signal we emit if we've hit something. Is it the one we emit? Yes. Use area 2D to detect the collision. Select the player node. Inspect a tab. And look for the list of signals. Where would that be? Oh, it's in node signals. Okay. Hit. Since our enemies are going to be rigid body 2D nodes, we want the body entered area 2D, body entered node 2D, body node 2D. A signal will be emitted when a body contacts the player. Click connect, and the connector signal window appears. Connectors down here. Godot will create a function with the exact name directly in the script for you. You don't need to change default settings right now. So on body, enter. And that would be down here. So when these things are overlapped, one's considered to have entered the other's space, and then that will trigger something. Note the green icon saying a signal is connected to this function. Yes. Okay, so on body entered. Oh, interesting. So hide is like the same thing that we're doing for whatchamacallit, when something disappears. So when you hit something, you lose your life, you disappear. Okay, hide, and then we send off the signal saying that we were hit. What does this mean? Must be deferred as we can't change physics properties on a physics callback. Right, so we're removing the physics capability of this object, but we can't do it during the on body entered. So that's why they have this set deferred function. So collision shape 2D, set new thing, but it's deferred. Oh, too many brackets. Set it to disabled. And I don't know what the true means, but I'm just still copying what they're saying there. Okay, each time the enemy hits a player, signal is going to be emitted. Then we disable player's collision so we don't trigger the hit signal more than once. Cool. So this is where they're talking about set deferred. Disabling the area's collision shape can cause an error if it happens in the middle of the engine's collision processing. That makes sense. So set deferred tells to wait until it's safe to make that function call and then do it. That's cool. Last piece is to add a function we can call to reset the player when starting a new game. All right, so this is what's going to get called here at some point. So start with a position. Right, so this allows us to reset to whatever position we want to, and then make ourselves visible again, and then re-enable the collision shape. It's weird that it has a member variable called disabled rather than a member variable called enabled that you would make false. So in saying false here, I'm enabling it. So it's kind of funny because sometimes it's like counterintuitive. Like this feels counterintuitive. We're using a double negative to make a positive. Okay, with the player working, we'll work on the enemy in the next lesson. Okay, let's... Oh, interesting. So the player doesn't exist until you call start. And at the moment, start is not anywhere. So I think this is the kind of thing where the scene that's doing stuff will be like, all right, I now need the player to start, and I will choose when to do that, and then we call the start function. Or maybe send a signal that does this. We'll find out later what that does. All right, I'm going to get rid of this hide for a second here and just test. It should be fine because we've added collision code, but there's nothing yet to collide with. Right, so it's still moving around fine. That's good. So that didn't test anything because we added the things for colliding and for restarting, but there's no way to test those yet. All right, creating the enemy. We create a mob scene, which we can then instance to create any number of independent mobs. Rigid body 2D named mob, and it's going to have an animated sprite collision shape and a visible on-screen notifier. I wonder what that is. Anyway, let's create it. New scene, rigid body 2D. We're going to name it mob. I like how they're just accelerating now. They're like, yeah, you know how to do it, so here's just the whole thing. Make it happen. It has an animation. It has a collision shape. Oop, oh, wait. Correct hierarchy. Visible on screen notifier 2D. I don't know what that is. We're gonna have to figure that out later. Don't forget to set the children so they can't be selected. So we do that up here. And where was it? Oh, it was in this scene. So we take the mob and we say group the node and its children. Okay. Select the mob node. And then in the inspector, rigid body 2D, set gravity scale to 0. Oh, otherwise it would fall. I should just type that in. In addition, collision object 2D, just here, expand the collision group and uncheck the one inside the mask property. This will ensure the mobs do not collide with each other. What is the mask? Oh, right. This is a detection. It's kind of a detection layer. So it's saying that they will not be on layer 1, but they can collide with objects on layer 1. So you can kind of separate things so that some things don't interact with each other in the physics engine, because if they did, then you'd be constantly checking them. Or in this case, they're allowed to walk through or over each other and not collide. So that must be the mask, which is a layer of objects that they can or can't collide with, I think. It's going to be like a bit masking kind of stuff here, but I don't really understand exactly how it works, but it'll be something like that, where this stops it from colliding with anything else, except for anything that's on layer 1, and the player is going to end up on layer 1, and the mobs are going to be on a different layer, I guess. Set up animated sprite 2D like you did for the player. So we had, how did we get to the animation again? Sprite frames? Fly, swim, and walk. Okay, so they've got a fly, swim, and a walk. So we're in new sprite frames, and we click on that to edit the sprite frames. That's good. I'm getting the hang of it here. So fly, and then enemy flying. I assume it's going to be this. Fly, swim, walk. 2 images for each animation in the art folder. Okay. Flying. Swim. Yes, Mitchell. It's a birdfish thing. So that actually, like, story checks out from before when you were like, what are they? Are they swimming and walking and stuff? And the answer was yes. Last one is walk. Okay. So we have 3 different possible animations here. Okay, animation speed property has to be set for each individual animation, adjusted to 3 for all the animations. Is that? Are we talking 3? Okay, set those to 3. You can use your play animation buttons on the right, the animation speed input field to preview your animations. Where is it? Oh, it's up there. I was like, it's got to be around here somewhere. Okay, so that's it. Doing that. And this is the swimming animation, and this is the flying animation. That's a strange way to fly. Doesn't look entirely aerodynamic, but we'll just roll with it. Okay. You can use, yep. Okay, stop that. Select one of these animations randomly so the mobs will have some... Oh, okay, so there's just 3 different types of mobs. It's not one thing. Some of them are walking, some of them are swimming, and some of them are flying. So they're actually different. Okay, fine. So each of the mobs gets a random animation. Like the play images, mob images need to be scaled down. Where was it? Animated sprite 2D scale property. Animation sprite transform scale property to be 0.75. All right, that shrinks them down a little. As in the player scene, add a capsule 2D for the collision. Now, the capsule 2D, was that this? Capsule shape 2D? Looks like it. And it needs to be rotated. Transform 90 degrees. Ooh, I'm going to have to type that in, otherwise I won't get exact. Talking about the aerodynamics. If bees can fly, then these can too. That's fair enough. Fair enough. I get where you're going there. All right, that's good enough. To align the shape with the image, you'll need to set the rotation. Yes, we have done that. And we save the scene. So now we have, in our file system, we have a player scene and a mob scene. And we're going to add a script to the mob. How do we do that? Right click? Yes, attach script. Rest of the script. In the ready, we play the animation and randomly choose one of the 3 animation types. Okay, so when it's readied, mob types. Wait, we're making an array here? Oh, I get it. So instead of just going, it's between 0 and 2, so there's 3 different options, what they're saying is actually go into the animation options and pick one of them. So that way, if we decide we don't like the way one looks and we delete it, it will still randomize between the 2 that are remaining. Or if we add 6 different animations, it will choose it. So this is like good programming, as opposed to me just going, I'll just hard code the 3 options, it'll be fine, right? This is a nice way to do it. Sprite frames. Get animation names. Where's my autocomplete gone? It's interesting that the autocomplete just kind of drops out sometimes. Sometimes it works fine, and sometimes it's just not there. And it knows it's right because it's changed the color and there's no errors. But it just didn't autocomplete for me. Okay, so you make an array of the different types of animation names that we have, and then we set its animation to a random pick from the array. Really strange. The autocomplete's super strange because that was just like muscle memory from before. But now it's not. Okay, there you are. There you are, taking your time. Oh, maybe it's one of those things where Godot's API is so large that sometimes it actually like can't look things up very quickly, even though it has them there. It still can't look them up immediately. Okay, so we play the animation. So we've created an array of the 3 animations. We've picked one at random, and now we play it. The last piece is to make the mobs delete themselves when they leave the screen. Connect the screen exited signal of the visible on... Oh, this is why we had visible on screen notifier. To the mob. Okay, so connect the signal screen exited. Connect. And then we get the function on visible screen notifier 2D screen exited. That's a mouthful right there. And they say to queue free. I assume that means take me out of the queue of objects that need to be updated. And queue free is a function that essentially frees or deletes the node at the end of the frame. Or maybe the queue means queue up things to be freed when the frame processing finishes. So at the end of the frame, this thing will disappear. This completes the mob scene. With the player and enemies ready, in the next part, we'll bring them together in a new scene. We'll make enemies spawn randomly around the game board and move forward, turning our project into a playable game. Right. So I was like thinking, when do I finish? But I'm thinking like, let's actually push through because I can probably like, it's only one more scene and then we'll have this thing playable and then it'll be like, all right, then we can finish up the stream there. Okay, main game scene. Create a new node. Oh, wait. Let's read it first. Create an add node named main. Create a new scene and add a node named main. Reason we're using node instead of node 2D is because this node will be a container for handling game logic. It doesn't have 2D functionality. Perfect. Makes perfect sense to me. All right, I should save the mob first. New scene. Wait. Create root node, other node. Node, pure node. Yep, okay. And we're calling this one main. I guess, you know, like the main function in anything is an abstract thing. It doesn't have any function of its own. It just calls other things. Okay, node main. Click the instance button and select your saved player scene. And so the player is in the scene now. Okay, add the following nodes as children of the main. So a timer. And we'll call this one mob timer. And another timer. Can I just press enter? Oh, wait, wrong place. Control Z. Good. Okay. Another timer. There's 3 timers. I'll just make the 3rd timer as well. No, I keep doing that. I need to have the main selected when I'm making a child of the main. So whichever one I'm selected, it'll child to that one. Okay, 2nd timer is score timer. Oh, right. So the longer you stay alive, the higher your score is. And a start timer. It's a delay. Yes. And then a marker 2D. Start position. To indicate the player's start position, set the wait time property of each of the timer nodes as follows. So the mob timer so every half a second we get a mob. And then the score timer, every second we get a point. And the start timer is a 2-second delay before starting things. In addition, set the one-shot property of start timer. Okay. You only ever get to start once, so we don't have multiple lives here. And set the position of the start position. Position will be in transform to 240 by 450. Roughly the center of the screen. Not exactly, but roughly. Okay, the main node will be spawning new mobs. We want them to appear at a random location on the edge of the screen. So we go to the main node and add a child path 2D named mob path. When you select path 2D, you'll see some new buttons at the top of the editor. Here? There we go. Control points. Yep. Select the middle one, add point. And draw the path by clicking to add points in the corners shown. To have the points snap to grid, make sure you use grid snap and smart snap selected. So use smart snap, use grid snap. Okay. And we've got our whole scene viewable here. Draw the path in clockwise order or your mobs will spawn pointing outwards instead of inwards. Interesting. Okay, so select this, add a point. It's nice with the grid snap, you don't have to be exact. All right. After placing point 4, click close curve. Which one is that? Close curve. And your curve will be complete. Now the path is defined, add a path follow 2D. Path follow 2D to mod path and name it mob spawn location. So it looks like what we're creating is a little like marker point that just goes around this thing. And then wherever it is at that time is where a mob appears. Node will automatically rotate and follow the path as it moves, so we can use it to select a random position and direction along the path. Scene should look like this. Player, mob timer, score timer, start position, mob path, and mob spawn location underneath it. Cool. Add a script to main. At the top of the script, we use export variable mob scene packed scene to allow us to choose the mob scene when we want to instance. So we can make copies of this scene, I guess. And we have a score. Click the main node and you will see the mob scene property in the inspector. You can assign this properties value in 2 ways. Drag the mob scene from the file system and drop it in the mob scene property. Click the down arrow and choose mob.tsn. Oh, wait. We need to save it first for it to exist. Oh, wait. No. The mob scene. Load, select mob scene. Right. Okay. So this allows us to make multiple instances of the mob. I get it. I was thinking main scene. I was like, why are we making multiple copies of the main scene? Right. Next, select the instance of the player scene. Under the main node in the scene doc. And access the node doc. Make sure to have the signals tab selected in the node doc. Yes. You should see a list of signals for the player node. Find and double click the hit signal in the list. This will open the signal connection dialog. We want to make a new function named game over, which will handle what happens when the game ends. type game over in the receiver method. Where am I? I lost where I was reading. Game over in the receiver method box of the signal and click connect. Right, so now we get a game over function that happens when the player is hit. Aiming to have the hit signal emitted from the player and handled in the main. Yeah, good. Add the following code to the new function. So when we hit game over, we take the score timer and we stop it. So that's your score at that point. And we stop spawning new mobs. And then there's a new game function. So when we start a new game, our score is 0. Oh, that was close. I think that comes in here. Hang on a second. I slipped and pressed a different key, but I had gone for the semicolon 100%. So that's the third count for the semicolon there. Okay. Score 0. Player start. And they get restarted at the start position. And then the start timer starts. So you got 2 seconds while the start timer runs. Mitchell saying, you're literally about to say we haven't had a count increase in a while. Oh, it was gonna happen. Especially as like I'm getting into flow now and I'm programming faster. It's like much more likely that my muscle memory to hit things with one of my fingers is gonna come through more often. So as I'm starting to actually get familiarity with this and start to just genuinely do it, rather than having to really slow down and figure out what's going on, yeah, I will definitely start to make those. Okay, now we're going to connect to the timeout signal of each timer to the main script. So for each of the 3 timers, open the signals tab and click connect the timeout. Okay, and those are good names for it, right? Yeah. Mob timer timeout. Score timer timeout. There's probably a quick way to do this and me click on everything, right? Can I double click and then press enter? Yeah, okay. Little bit quicker. I think I'm still really slow because I don't have muscle memory for how to do things quickly. Also, probably shouldn't be trying to speed up too much yet until I learn everything. Now, each of these timers gets some code. So start timer would call new game, I assume. Start timer timeout. We just start the other timers on the start timer timeout. Right. Mob timer starts. And the score timer also starts. Score timer, so every time the score timer completes, the score goes up. Now, mob timer timeout, we create a new mob, and this is going to be more fiddly, and there's a lot of code there for that. Okay, we create a mob, pick a random starting location along the path 2D to set the mob in motion. Path follow 2D will automatically rotate as it follows the path. So if it's going around, then we turn it 90 degrees to the right and aim them inwards, I guess. Oh no, they're saying when we spawn a random value between 150 or 250, oh, for how fast, right? Because it's boring if they move at the same speed, sure. New instance must be added to the scene using add child. Okay, so this is the meat of this, is the spawning of the mobs and getting them moving. So we create a mob. Right. Mob scene was the thing that connected it to this mob script. Well, not mob script, mob the whole scene. And we instantiate by creating one copy of it. And then we have we're creating their spawn location. Mob path slash mob spawn location. Okay, so to go down the hierarchy, you use slashes, which kind of makes sense how we do it in a file system anyway. Mob spawn location progress ratio. Interesting. So this is how we're doing linear interpolation along a line is saying the progress ratio. So I'm going to assume that 0 is the start and 1 is the end. And we're just making a random float. So the assumption might not be that 0 and start is the start and 1 is at the end, because the random float could be any scale. I don't know. Oh no, it's not. Random floating point value between 0 and 1. So it is. This is like a linear interpolation along that path. Okay, that's cool. I like the way that works. Mob position is equal to the mob spawn location's position. Very strange sometimes when the no, no, I did not want that. When the autocomplete doesn't go to the thing that it actually has. Like all nodes, well, all the 2D nodes have a position. Okay, mob's direction. Very strange. Okay, so the mob spawns location rotation plus pi on 2. So this is rotating at 90 degrees inwards. So that's what I thought. It would, because it's following the path around, you just take a 90 degrees turn inwards and you aim straight in. But we are not going straight in for all of them. We're going to have some random. So random float within a range. Oh, right. So a quarter pi in each direction. So that way they don't all come straight in. They can come on an angle. Quarter pi being 45 degrees. Am I right? Yeah, 45 degrees. And so we set their rotation to be that direction that we've just built up with these. Okay, so the mob gets instantiated. We find the path, the position on the path, and that sets their position. So I'm going to separate these things a little. So gets created, finds a point for where it's going to be, then sets a direction. And then we set its velocity. Velocity is usually a vector 2. And we're doing random in a range again. Yes. For 150. And these are floats, so they're going to be 0.0. I wonder if they'd work without the 0.0. I feel like they would. But that's okay. And then we change the mob's linear velocity. I didn't know it had a linear velocity. Not sure how different that is from velocity. But that might be the length of the vector rather than the direction, because the direction's already been set. So I think when they say linear velocity, they mean speed. Oh, not necessarily. So they're saying that the mob's actual velocity is equal to whatever the velocity was here, and then rotate it in a particular direction. And then we spawn the mob that we have just created with all this stuff. Pi, yep, okay, radians. Oh, test the scene. Let's test the scene, make sure it's working. Add new game call to ready. Okay, so where's ready? Up here? Yeah, okay, ready has to have something. New game. New game here sets the score at 0, sets the player, starts the start timer. Start timer starts the other 2 timers. And then it rolls. That seems like it's correct. Let's save that. Also, assign main as our main scene, the one that runs automatically when the game launches. Press the play button, select main scene when prompted. No main scene has ever been defined. Select one. Select main. Okay, so that's our main. Game starting. Oh, there we go. Oh, yes. Oh, I died. That was more than 2 seconds before it restarted. Okay, so some stuff is working. I was moving, I collided with something, and I hit game over. But there was no restart. So some stuff is working. That's good. We've got like a sort of a game. Okay, maybe there's something here that I forgot to do. When you're sure everything is working, remove the call to new game from ready and replace it with pass. Oh. Why? Oh, because the UI is going to make it work. So that's fine, because I think, all right, when we die, we call game over, and that stops the timers. That did not call new game. So that's fine. Yeah. Yeah, I think we're okay. We're totally fine. Because game over was not restarting. So we've not written any code to restart. So all we're doing there is testing whether one instance of the game works. So we got our enemies coming in random directions. We got this slightly bullet hell feel to this thing. And there is a score. But because we have added no UI element, oh, there I go. Because we haven't added any UI elements, we don't actually know what my score was. I wonder if there's a debugger. Ooh, errors. Delta is never used. Body is never used. Yeah, that's fine. I'm not actually debugging at the moment, am I? So there's no variable tracking going on right now. Oh well, so I can't see what my score was, but that's fine. If I wanted to see what the score was, I would have to add the interface, which is what they're talking about here. What's our game lacking? Some user interface. In the next lesson, we'll add a title screen and display the player's score. All right, we come this far. We're gonna finish it because this is the last thing, and then finishing up. Okay, final piece our game needs is UI to display things like score, game over message, restart button. Create a new scene. Other node and a canvas layer. And we call this HUD. Let's just draw our UL elements on a layer above the rest of the game so the information it displays isn't covered up by any game elements, like the player or mobs. Score, changed by score timer, a message such as game over or get ready, and a start button to begin the game. Basic UI, basic node for UI elements is a control. Two types of control, a label and a button. Create the following as children will have known: 2 labels, a button, and a timer. I feel myself like sort of accelerating now. Getting into the like, yeah, I can create this stuff. I've done it before. It's interesting how it's like just like an hour and a half or so on this, and it's like enough to get a good idea about how you're gonna do things. Okay, so this is the score label. The second label is the message. Button is the start button. And the timer is the message timer. Click on score label and type a number into the text field. Default font for control nodes is small, doesn't scale well. Oh, right. Okay, so let's just do this. Oh, so we're doing this so we can see what it does. Font file included in the game assets. Uses font under theme overrides. Where are they? Theme overrides. Fonts. Choose load and then select Zolonium Regular. Okay, that's our new font. Font size is too small, increase to 64. Is it up here? No, it's going to be here. Font size 64. Okay, that's nice and big. Repeat the changes for the message and start button nodes. Okay, so we'll just put some text in here so that we can see it. And we theme override the font to the same one. Set the font size to 64. All right. I'm just going to move you a little so I can see you. And then did the start button have something as well? Start button also is getting text. Theme overrides fonts again. Load that font. 64. Right, so we have our message text and our start button. We'll move them into proper positions later, I assume. Anchors. Control nodes have a position and size. They also have anchors. Anchors define the origin reference point for the edges of the node. Arrange the nodes as shown below. You can drag the nodes, place them manually, or for more precise placement, use anchor presets. Ooh, anchor presets. Score label. Text to 0. Shouldn't put an enter on the end of that. Set the horizontal and vertical alignment to center. Choose anchor preset to center top. Where is our anchor? Did I scroll past it? This is all text stuff. This is theme. Choose the anchor preset center to. Oh, right. It's up here. Cool. I was thinking it would be somewhere in here. Okay, message. Add the text dodge the creeps. Set horizontal and vertical alignment to center. Set auto wrap mode to word. Oh, okay. Otherwise, the label will stay on one line. Under control layout, transform, size in X to 480, so it's allowed to take the whole width of the screen. Anchor preset center. Right, so that one will be right in the middle of the screen. And then the start button. All right, we're giving it a capital at the start. Control layout, transform, size to 200, and the size Y to 100. Anchor preset center bottom. Control layout transform, position Y to 580. So that just moves it up off the bottom a little. Okay, message timer, wait time to 2. And set the one-shot property to on, because this one only goes once. Now add this script to the HUD. Okay, so add HUD. Oh, no. Attach script. Extends canvas layer. It has a signal called start game. Now to display a message temporarily, such as get ready, we add the following code. So function show message with certain text. Message text equals text. We show the message, and then we start the message timer. Oops. Right, so the message timer goes until you've had time to read it, and then it disappears. We also need to process what happens when the player loses. Code below will show game over for 2 seconds and return to the title screen. After a brief pause, show the start button. Okay. Show game over. Oh, so this is using these assets to make stuff appear. So the message will appear, and that the message was dodge the creeps. And then game over, show message. Oh, that's interesting. So you're overriding. Oh, no, this is just, yeah. You're overriding whatever text is in the message. So the message text equals the input text. Right, so it's not going to be dodge the creeps. This is going to be whatever you input. And then wait for the message timer to time out. Right, so this is like, this message goes up for 2 seconds, then disappears. Oops, wrong one. Message text. Right, so you say game over, and the message timer times out, and then you switch the message to dodge the creeps, and then you wait for another timeout, and then you show the start button. And then I assume the start button will send the signal to start. Excuse me. Dodge the creeps. Then we show that message. Oh, and so this isn't actually the message timer. This is make a new timer. So this is create timer. for 1 second. 1 second. Get tree. So I assume this is just like we're somewhere in our hierarchy and we're creating a new timer. Create timer for 1 second. We let it time out. And after that, we show the start button. Interesting. When you need to pause for a brief time, an alternative to using a timer node is to use the scene trees create timer. So if you just want a little delay, so you just want a 1 second delay, you do it like that. This is like the same as just going in other languages. And it's like, no, wait does not exist. Oops. Okay. Add code below to HUD. We're still in the HUD script, right? Yes, we are. Should probably save this to update the score. Oh, sleep. Yeah, sleep rather than wait. Oh, I wonder if they've got sleep. Nope. That's okay. Oh, no, no. It'll be in here. Oh, they do? No, no, they don't. Okay, fine. All good. So this is the way to do it. Wait for a timer that you've created to time out after 1 second. That's a lot. 3 components and a keyword to just pause for a few seconds. Okay, we're making a function to update the score. And we say the score label text is equal to a string of score. So the score is happening in one of the timers, isn't it? Yeah. Okay. So we assume that this is going to have to get called at some point. Connect the pressed signal of start button and the timeout signal of message timer to the HUD node. Okay. Connect the pressed of start button. So start button, we go find pressed, and we connect to that. To HUD. Yes. And then timeout of message timer. All right, so they're both connected. On start button pressed. So when you press the start button, we hide it. And then we, see, this is why it wasn't restarting the game. Because we weren't sending out the start signal previously. Okay, message a timeout. That means we've looked at the message for long enough, and then we hide the message. All right, and now we connect the HUD to the main. Now we're done creating the HUD scene, go back to the main. Oh wait, it's just here, isn't it? No, not necessarily. Oh yeah. Instance the HUD scene in main like you did the player scene. How did I do that? Instantiate child scene? Was it that thing? Yes. HUD. Okay, so the HUD is now a child of the main the same way the player is. Okay, good, good, good. This requires a few additions to the main scene. In the node tab, connect the HUD's start game signal to the new game function of the main node. Connect. Pick button. Connect a signal to the new game. Oh, cool. So this means we can say this signal attaches to this function. Lovely. So now when we click start game, it goes to the main, goes into the script, calls the start game function. And so you can connect signals, and then when you change stuff, you would reconnect them or something. But it's nice to be able to connect into functions you've already written, so you don't have to do the connect thing and have the function appear and then write code in it. So new game there is now connected because it's got a green thing there. Or type new game, verify green connection icon now appears. In new game, update the score display and show the get ready message. So in new game, we add these things. So when we update the score, we also go HUD, update score to the new score, player start position, start timer, and then after this we can show the message. Okay, I'm going to separate those a little so it's a bit more readable. In game over, we also need to call the corresponding HUD function. So HUD show game over. Cool, 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 cool. Finally, on score timer timeout, yes, score plus equals 1. So if we go to the HUD and we say update score to the new score, which is 1 higher than it was before every time the score timer times out, so that will update the what's getting shown as the score. Now we're ready to play. Remember to remove the call to new game from ready if you haven't already, otherwise your game will start automatically. Okay, so nothing in the ready. It says we're ready to play. Okay, ready to play. Let's play. Dodge the creeps. Oh, click the start button, get ready, and go. And there's a score going at the top. It's totally working. It's working. Haha. Game over, 14 seconds. Dodge the creeps, do you want to start again? And then like it'll just wait here until I press start. And then we go again. The cycle is working. Beautiful. "11 seconds that time." All right. All right. Let's stop that there. And what else are they saying? If you play until game over and then start a new game right away, if you start it immediately, the creeps might still be there. It'd be better if they all disappear at the start of a new game. We just need to wait to tell all the mobs to remove themselves. We can do this with the group feature. Okay. So this is good. Are the creeps too big? Maybe the creeps are too big. But also, you know, it's just a demo. We don't have to balance it. It'll be okay. I think like pretty soon we'll move on from this and do something new, but it's very, very good to have done it actually. Let's just do this last thing because, although no, it's 10:50. No, it's all right. I've been streaming for 3 hours and it's late. We can do cleanup next time, but happy to be in a situation where we've done the tutorial to the point where we've completed the creation of a game. So pretty happy with that. It's just you and me now, Mitchell, by the looks of it. I think everyone else is gone. So happy with that. I'm gonna, is that all saved? Yes, that's all saved. Gonna close that. Pull this up. Oh, we're so bright. And what are we now? 23rd. we have completed the tutorial for creating our first 2D game. It's functional. There are some more things to do, like clean up, etc. We'll get to that next time. All right. I think that's a good time to wrap it up. I actually earlier at dinner I was like, oh, I'm feeling a bit tired. I don't know if I'll do like a long stream tonight. I might like cut it off at like 2 hours so I can chill out. And then it's like, no, we're so close. We're so close. We want this playable. Gotta push. But it's good. It's fun to do that. So we have a playable demo, which has actually been quite good to just kind of go through the motions of how to do stuff in Godot. And I feel much more confident now in things I might be able to make in the future. So, good to see. Lots of fun. Actually, no, there is someone else here now. I see 2 concurrent viewers. Oh well, whoever else is there, hello, as well as goodbye. Thank you for coming along. I'm going to wrap up the stream there. I thought this was a really good one. It was actually like super productive. Did a lot of coding and actually learnt. Now that I know about the GD script and stuff like that, I actually kind of think that I've probably got enough now to be able to be like, all right, we can make a game out of this now. There's a whole lot more work to do to figure out exactly what I actually want to make in the game, but there's a lot of stuff I can now use, and with these basics can sort of start to build things up. So very happy with that. I will see you all next week. And next week we will finish the cleanup. And I think then we will jump back into the design thinking. We'll put the design hat back on and go, okay, first prototype, simple things, get 1 level working. What do we need to do? And so I will define exactly what we need to do. And then after that, we will then go and actually make it into Godot and stuff like that. So I think this would be cool. This is fun. I like the engine, and I think it works. It's enough that I'm like, I don't think I need to like look at other engines now. We're gonna go with Godot and see where it takes us. So I will see you next week, and we'll figure out exactly what our sort of first prototype is. Okay, see you later.